Throughout human history, comets have always inspired both fear and fascination. Long before telescopes existed, ancient civilizations watched the night sky and noticed strange objects that appeared suddenly, glowing with a ghostly tail stretching across the heavens. These hairy stars, as they were once called, seemed unpredictable and mysterious. To the Babylonians, Chinese astronomers, and medieval European observers, comets were often interpreted as omens, warnings of war, famine, or the fall of kings. Today, modern astronomy has replaced superstition with scientific understanding. We now know that comets are essentially frozen relics from the earliest days of our solar system. Billions of years ago, when the sun and planets were still forming, countless icy fragments remained scattered across distant regions of space. These remnants made of rock, dust, and frozen gases like water, carbon dioxide, and carbon monoxide eventually became what we now call comets. Most comets reside in two distant reservoirs surrounding our solar system. The first is the Kuiper Belt, a disk of icy bodies located beyond the orbit of Neptune. The second, far more distant region is known as the Oort cloud, a vast spherical shell of icy debris that may extend nearly halfway to the nearest star. Occasionally, gravitational disturbances, perhaps from passing stars or galactic tides, send one of these icy objects falling toward the inner solar system. As the comet approaches the sun, the increasing heat begins to vaporize the frozen gases inside it. This process, known as sublimation, releases enormous amounts of gas and dust into space. The escaping material forms a glowing cloud around the comet called a coma, while solar radiation and the solar wind push the dust into a spectacular tail that can stretch millions of kilometers across space. This process is familiar to astronomers. Thousands of comets have been observed behaving in roughly the same way. Each one follows the same fundamental pattern. Approach the sun, develop a tail, brighten dramatically, and then retreat back into the darkness of deep space. But sometimes, the universe sends us something completely different. In recent years, astronomers have discovered a rare and extraordinary category of objects known as interstellar visitors, cosmic wanderers, that did not originate in our solar system at all. Instead, they were born around other stars and have traveled across the vast emptiness between stellar systems before briefly passing through our cosmic neighborhood. The first confirmed example appeared in 2017. It was a strange object detected by a telescope in Hawaii. Its name was Oumuamua, a Hawaiian word meaning scout or messenger from afar arriving first. The object puzzled scientists almost immediately. Unlike any comet or asteroid previously observed, it showed unusual motion and had a highly elongated shape. Even more intriguingly, it exhibited slight acceleration that could not be fully explained by gravity alone. Then, just 2 years later, astronomers detected another interstellar visitor, Comet Borisov. Unlike Oumuamua, Borisov behaved more like a typical comet. It had a clear coma and tail, and its chemical composition appeared broadly similar to comets found within our own solar system. This discovery reassured scientists that interstellar comets might not be entirely exotic after all. Yet the story did not end there. Recently, astronomers using automated sky survey telescopes identified another incoming object moving through the solar system at extraordinary speed. This object was eventually designated 3I Atlas. The name itself carries meaning. The 3I indicates that it is the third confirmed interstellar object ever detected passing through our solar system. The Atlas refers to the Asteroid Terrestrial Impact Last Alert System, a network of telescopes designed primarily to detect potentially hazardous asteroids approaching Earth. At first glance, 3I Atlas appeared to be another interstellar comet rare, but not entirely unexpected after the discoveries of Oumuamua and Borisov. However, as astronomers began analyzing the data more carefully, they realized something remarkable. 3I Atlas was behaving in a way no comet had ever been seen to behave before. Its trajectory clearly indicated an origin outside the solar system. The object was moving far too fast to be gravitationally bound to the Sunday. In fact, it was racing through our planetary neighborhood on a hyperbolic orbit, meaning that once it passed through the solar system, it would continue onward into interstellar space forever. But it wasn't just the speed that caught scientists' attention. As telescopes tracked the object's motion over time, they began detecting something unusual in its acceleration. Normally, comets experience what astronomers call non-gravitational acceleration. This occurs because jets of gas escaping from the comet's surface act like tiny rocket thrusters. When sunlight heats the comet, pockets of gas erupt outward, pushing the comet slightly in the opposite direction. This effect is well known and can be measured. For decades, astronomers have used mathematical models to predict how these gas jets influence a comet's trajectory. Yet in the case of 3I Atlas, the acceleration seemed unusually strong, much stronger than expected. At first, scientists assumed the explanation was simple. Perhaps the comet contained unusually large amounts of highly volatile ice substances that evaporate easily even at great distances from the Sunday. If that were the case, the comet might be producing stronger jets of gas than typical solar system comets. But when astronomers analyzed the light coming from the comet, studying its spectrum to determine the chemical composition of its gases, they encountered another puzzle. The amount of gas detected in the coma did not seem sufficient to explain the magnitude of the acceleration being observed. In other words, something was pushing the comet more strongly than expected, but the usual explanation, escaping gas, didn't fully account for it. This raised a startling possibility. What if 3I, Atlas, was not just another interstellar comet? What if it represented an entirely new category of celestial object? Such a possibility immediately attracted global attention within the astronomical community. Observatories around the world began scheduling additional observations. Some of the most powerful telescopes ever built were directed toward this mysterious traveler. Space telescopes, ground-based observatories, and advanced spectroscopic instruments all joined the effort to study 3I, Atlas, in as much detail as possible. Several theories quickly emerged. One idea suggests that the comet's surface may be extremely porous, almost like a sponge made of ice and dust. If sunlight penetrates deeply into such a structure, trapped gases inside could suddenly escape in powerful bursts, creating stronger than expected thrust. Another possibility is that the object may be gradually breaking apart. If fragments of material are being shed from the comet's surface, they could produce additional momentum that alters the object's motion in subtle but measurable ways. Some scientists even propose that interstellar objects may have very different chemical compositions compared to comets formed in our solar system. Because they originated around other stars, the conditions of their birth environments could have been radically different. If this is true, then studying 3I, Atlas could offer a rare glimpse into the chemistry of distant planetary systems, and that is what makes interstellar visitors so valuable to science. Every comet from our solar system tells a story about the formation of our own planetary system. But interstellar objects carry stories from entirely different star systems, places we may never visit but can still learn about through these wandering messengers. They are, in a sense, cosmic samples that have been delivered to us by chance. For millions, or perhaps even billions of years, objects like 3I, Atlas, may wander through the galaxy, occasionally passing near stars or planetary systems before continuing their journey through the darkness. Most of them pass unnoticed, but every once in a while, one crosses the path of our telescopes, and when that happens, scientists have a brief window of opportunity to study it before it disappears forever into the depths of interstellar space. That is exactly the situation with 3I, Atlas. At the moment, astronomers are racing against time. As the object travels through the solar system, it will gradually move farther away again, becoming fainter and more difficult to observe. But before it vanishes, it may reveal something extraordinary. Because if the early data are correct, then 3I, Atlas is doing something no comet has ever been observed to do before. And if scientists can uncover the reason why, it could reshape our understanding of how planetary systems form not just in our solar system, but across the entire galaxy.